Okay, we hear constantly about this aggressive, high-stakes race to build the future, right? We're talking mass electrification, advanced renewable energy, and next-gen military defense systems. But beneath the surface of all this massive industrial shift, there is a hidden, incredibly intense conflict happening over the specific materials actually making that transition possible.
I mean, think about it for a second. What actually powers the high-efficiency electric motors in those new EVs, or the massive generators spinning inside offshore wind turbines, or even the precision guidance systems in advanced military hardware? The wild reality is that all these cutting-edge innovations are dangling by a single, very fragile geopolitical thread.
And to put that into perspective, we are looking at a choke point of terrifying scale. Right now, the People's Republic of China controls an estimated 91% of the world's separation and refining capacity, alongside a staggering 94% of sintered permanent magnet manufacturing. When we talk about global supply chain vulnerabilities, this is literally one of the most highly concentrated nodes in modern industrial history.
Now, before we get too deep, let's make sure we understand exactly what these elements are. Rare earth elements, or REEs, are a family of 17 chemically similar metallic elements, and they are absolutely strictly indispensable for making permanent magnets. But here's the kicker. Processing them is not your standard mining operation. You can't just dig them out of the ground like iron ore. Because they share nearly identical chemical properties, separating them is a bit like trying to unbake a cake. It requires this absolute mastery of solvent extraction chemistry, a fiendishly complex chemical nightmare involving hundreds of cascading steps, and frequently, you're dealing with radioactive byproducts.
So here's our roadmap for this explainer. First, we'll look at China's invisible human moat. Second, the weaponization of knowledge. Third, the Western counteroffensive. Fourth, some project successes and costly failures. And finally, rebuilding the talent pipeline. Let's jump in.
Starting right off with Section 1, China's invisible human moat. Okay, let's shatter a pretty common misconception right now. A lot of folks assume China's dominance is just geological serendipity, right? Like, they just happen to have all the rocks. But viable deposits exist everywhere, from Australia to North and South America. China's true weapon isn't subterranean, it's their invisible human moat. Beijing realized decades ago that sustained market dominance required an absolute monopoly on intellectual superiority. So they constructed a highly engineered three-tier educational machine explicitly designed for geopolitical advantage. First, you have specialized universities right near major mining hubs. Take the Baotou model, for instance. Students there take over 100 hours of highly specialized coursework just in complex separation metallurgy. And upon graduation, these cohorts can literally walk down what is known as Rare Earth Street, an actual corridor lined with state-owned refiners, and step straight into advanced operational roles with zero latency. Add a sprawling network of over 40 dedicated state research labs to the mix, and you have an ecosystem perfectly optimized to seamlessly transfer technology from academic theory straight into commercial-scale production.
You know, the best way to think about this is like a hardware versus software analogy. The West is currently throwing billions of dollars at building the physical hardware, the refineries and mines. But China possesses the accumulated software, the hyper-specialized technical knowledge, and the discrepancy is just staggering. The entire United States produces roughly 200 generalist mining and metallurgical grads a year. Meanwhile, China enrolls more than 500 students annually strictly into hyper-specialized rare earth degree programs.
Which brings us to Section 2, weaponizing knowledge.
Beijing absolutely knows the West is finally waking up to this reality, and they are actively locking the doors to their intellectual fortress. We're tracking this rapid, sequential escalation of what industry analysts call knowledge protectionism. In 2023, China effectively banned the export of all rare earth extraction and separation tech. Then by 2025, they rolled out export controls targeting individual heavy elements that are vital for military motors. And jumping to 2026, they implemented strict automated tracking controls, mirroring extraterritorial trade laws, just to block any magnets that use even microscopic traces of Chinese-sourced materials or intellectual property.
But the absolute most intense reality of this lockdown really involves the human element. The state apparatus has systematically limited contact between their domestic rare earth technicians and foreign counterparts. In fact, specialized Chinese engineers and researchers reportedly had their passports seized by government security entities. They just aren't viewed merely as corporate employees anymore. Their actual brains are considered highly classified national security assets.
Moving on to Section 3, the Western counteroffensive.
So, facing this immense, multi-layered vulnerability,
Allied nations are frantically deploying billions of dollars to fight back. But the United States and Europe are reading from entirely different playbooks. The U.S. treats this almost exclusively as a national security issue. Their response relies on aggressive deregulation, stripping away environmental permitting barriers, and essentially functioning like a venture capital firm by taking direct equity stakes in critical material operations. They're going all in on an Operation Warp Speed approach. The European Union, on the other hand, recognizes it has virtually no domestic primary rare earth production to begin with, so their focus is on resilience through interdependence. They strictly refuse to compromise on their ESG standards. Instead of direct state equity, the EU uses development banks to coordinate global strategic partnerships, and they lean heavily into recycling to create domestic urban mines.
Let's look at Section 4, Successes and Costly Failures. All right, so we've got the high-level policy, but what actually happens when Western money hits the ground? Let's move from theory to project-level reality to see these breakthroughs and the severe bottlenecks outside of China. To ground this in some specifics, let's contrast two heavily capitalized projects right in Texas. On one hand, you have MP Materials. They're successfully advancing a vertically integrated rare earths to magnet supply chain completely on American soil, backed by massive Department of Defense loans. It is a huge domestic win. But then, look at Linus Rare Earths, historically the most successful producer outside China. They received coveted Defense Production Act funding for a state-of-the-art facility in Texas, but were forced to completely shelve it in 2025. Why? Because of labyrinthine permitting disputes, spiraling capital costs, and a systemic lack of localized engineering talent. It just proves that government mandates and giant piles of funding aren't magic wands.
And that brings us to a sheer financial cliff: $60 billion. That is the estimated immediate, high-risk investment required globally just to meet the baseline demand for magnet rare earths from non-Chinese suppliers. And as that Linus failure showed us, even if you have the capital, without the talent, it leads directly to industrial stagnation.
Which perfectly sets up our final part, Section 5, Rebuilding the Talent Pipeline.
Because you can't just buy your way out of a generation-long knowledge deficit, the West is being forced to get incredibly creative to rebuild its talent and innovation pipeline. Allied nations are pursuing some really novel workarounds to bypass traditional hard rock mining choke points. We're seeing incredible initiatives, like a $67 million Department of Energy grant aimed at extracting critical rare earths directly from industrial red mud tailings in Louisiana. They're literally turning toxic waste into a strategic asset. Academic centers like the Colorado School of Mines are launching massive innovation hubs to train the next generation of metallurgical engineers. Meanwhile, major corporations like Apple are leaning hard into closed-loop recycled magnet sourcing, aligning perfectly with Europe's heavy push into urban mining. They are completely reimagining the whole supply chain.
Which leaves us with this final, absolutely vital question. We see the financial investments, and we definitely see the political will. But to break a meticulously crafted monopoly that was decades in the making, we really have to look beyond the ore. The capital is deploying, but the structural human capital gap remains profound. So can the West successfully mine the specialized talent required for a green future? Or are we permanently locked out of the supply chain? It's a sobering thought, but one thing is absolutely clear. To win the global resource war, we must first win the generational talent war. Thanks for joining me on this explainer.